Go.
Okay, class. Today what we're going to do, we are going to talk about plate tectonics. We've been talking about this for about a week and a half now. And what I want to do, I want to talk to you a little bit about earthquakes and then something else why after I talk about the earthquakes. Now, we know that geologists use volcanoes and earthquakes to try to figure out what the internal structure of the earth is. Last week we did an assignment talking about the different layers of the earth. And you should know by now that we have the crust, the mantle, the outer core, and the inner core. And what those, and different states of matter of each of those core, of each of the layers. And the way we know that is because scientists are able to look at volcanoes and earthquakes. Now, the earthquake waves move slowest through liquids, and they move faster through dense objects or dense solids. So if you look here, class, I have on the board, I have some words that I want us to talk about today. The first one is called the epicenter. Epi means above. So it is a place above the origin of the earthquake. Then we have the focus. The focus is a place where the earthquake originated. And the last one is the fault. It's a crack in the earth. And I have an image that I want to show you on my iPad. Just give me 1 second here. I'll show you the image. And you see right here, Jimmy, can you see that image? Can you get that close, please? If you see that, you see here that we have the epicenter, which is directly above where the earthquake originated. And then we have the focus. That's where the earthquake originated. And then we have the fault. The fault is simply the crack in the earth. And along that crack, rocks are slipping, and that's what causes the earthquake, when the rocks slip or move. Okay, so we have that. Now, my helper, you know who he is. You saw him last time when we had a video. My helper, James Penix, my son. Come on, James, say hi.
Hi.
All right, so what we're going to do, we are going to demonstrate this. So, James, you ready? So, first of all, I'm going to just explain this to you a little bit. We have here, it says plate A and plate B. Now, we haven't talked about plates yet, right? So, but the earth is broken up into plates, and these plates move, okay? So, here we have plate A and plate B, two different parts of the earth. And James is going to pull this, and we should be able to see some waves being formed. So you guys, you ready, James?
Glasses.
Oh yes, we got to put on our goggles. We don't have goggles, so we had to use glasses. Okay? So here we go. All right, James, ready?
4, 3, 2, 1.
Okay, now you see here, here's a small wave. Can you see that wave? That's the wave. Now, so scientists use a tool called a seismogram to measure the waves. A seismogram, okay? So this tool, even though this is not an official seismogram, it is a model to show what scientists are able to see. So when the rocks are slipping, as indicated by the breaking of our toothpick, then waves are going to be generated. P waves and S waves, but we don't care about those names right now, okay? All right, good. So that is demonstration. Let's try it one more time, Jane. Want to try it again?
Yeah.
And maybe we can get a bigger wave this time, huh? Can you help put this up? There you go. Put it right underneath there. Tape it. Okay. That's taped down pretty well, I think. Okay, we're gonna try it again. And my daughter Jamia, she's helping today too. She's really happy to be helping. You see the big smile on her face? I was just being funny about that part. Okay, anyway. So here is, okay, so ready? You want to try this time, Jenny? How about you try this part this time? Okay, let's switch it this time. Why not? Okay, you get your goggles on so you don't hurt yourself. So you know what you're gonna do, right? You're gonna push one and you're gonna hold the other one, right? Okay. This one right here has to be the one pushing on the right. Okay, ready? 4, 3, 2, 1. Okay, there's no way that formed there. So we gotta try it one more time. So we're going to do it the way James wants to do it. He says I'm supposed to do it a little differently. So we're going to try. We're going to try his way. Why not? Why not? Because that's what parents do. They listen to their children sometimes. Oh, that wasn't very nice. Okay. Okay, here we go. James, you do it the way you're supposed to do it. You put it in there. Yep. Mm-hmm. So I'm just going. You want me to pull it, right? 4, 3, 2, 1. That's right.
I'm supposed to move this one.
Okay, do that one then. Okay, go ahead. Do whatever one you think. Ready? 4, 3, 2, 1. Oh, that was some better waves there, Jane. I think you're right. Look at that. Jimmy, can you see those waves there? Okay, good. That's good. Okay, now what we're going to do, we're going to do the next part of my activity. And, okay, class, so we just finished the demonstration with the earthquake. Now, I want to talk about how do scientists determine how destructive an earthquake is. How do they label it? So what we have here, if you can look here, Jimmy, can you come close to Jimmy? Here we have an earthquake strength chart. And on the left side, we have what's called the Mercalli intensity. And here we have the Richter scale, which you are probably more familiar with. So if you look on the right-hand side, the strongest earthquake is seen by having the number 8. The one that is not as strong is seen by having the number 1. So look at the things that can possibly happen because you have an earthquake that is measured at an 8. It says total destruction. Objects are thrown into the air, river courses, and the topography is also altered. So lots of things happen because of earthquakes. Okay. Now over here, this is a descriptive way. Using words to describe the earthquake, okay? So let's finish that. We're done with that. Now what we're going to do, class, I want to talk about what would happen. Do you see my son here, James, here? Can you get closer to what he's doing to me here? He's putting together a puzzle. How many guys like puzzles? Anybody like puzzles? Well, he's putting together a puzzle right now. Now, we may not have all the pieces, but you'll see why in a second why I'm talking about puzzles. Anyway, let me ask you a question. If, let's say, 1 million years into the future, that we would find, let's say that I would find some palm trees in Hawaii. Now, wait a minute. Let's say that in 1 million years in the future, Hawaii is frozen. Okay, it is a really cold place 1 million years in the future. But let's say that you were in Hawaii in 1 million years and you found some palm trees. What would you say about the climate of Hawaii in the past? You would say what? That it was what? Somebody help me.
Warm.
It was warm. That's right. Now, why do I say that? Well, because I want to talk about somebody named Captain Robert Scott. Captain Robert Scott, he found some warm tropical plants in Antarctica. And Antarctica is what? What kind of temperature do we have in Antarctica? Come on, Jimmy, tell me.
Well, cold.
We have cold weather in Antarctica, exactly. Now, if it's cold, and Captain Robert Scott found a Glossopteris plant. Put this on the board. Put this on the board. He found a Glossopteris fern plant in Antarctica. Okay. Captain Robert Scott. You need to know that name. What's his name, everybody? Captain Robert Scott. He found this in Antarctica. That's spelled right? Probably not. In Antarctica. Okay. Okay. So he found this thing. Okay. So he's trying to say, well, why is there this fern plant in Antarctica, which is supposed to be a tropical plant? Why is it found in Antarctica, which is really cold? See. So he found this fossil of this fern plant. Now, I want to show you, class. I want to show you. I got my notes right here. I only have notes because I always forget something. Anyway, I have my notes right here. And I'm going to show you. Here are some pieces. Can you see this? I'm going to get rid of this right now. This serve this purpose. So let me just put this aside. I'll just put it aside. Okay, so here we have some places here. So we got some places here. And I don't want to put them in order because that's the whole point. See how he's putting together a puzzle? Your assignment day is you're going to put this puzzle together, okay? Now look, we have some fossils here. Okay, we have some things here. This is a mountain, and we have some little blue guys, some red guys, some green guys, okay? I'm trying to figure out who these guys, okay? So we look here, we can see here in our book, and you're gonna have these same pages for your assignment, don't worry. We can see here that the green one is the Glossopteris. See the green Glossopteris? We're gonna use this as evidence for how how the continents were once put together, okay? So here we have Glossopteris. Here we have the Mesosaurus. Here so the Mesosaurus, little blue guys here. And here we have, there's a hard word here, Signatus, are the little orange guys, okay? And then we have the Lystrosaurus, and then we have the mountain ranges. So these are going to be, these little fossils are pictures, because that's a mountain's obviously not fossil, but these fossils and the picture of the mountain, those are going to be pieces of evidence that you use for assignment day to put these pieces back together. So your assignment day is this, class. You're going to, okay, you're going to put these back together. Now, I don't want to tell you the names of these places, okay? Because I want you to try to figure out your own. But look here. Can you show this to me, Jamia? This little orange piece here, I do want to point this one out to you. The orange piece here, that is India, okay? So I want you to put the pieces together as if they were one landmass. Okay, we call that one landmass Pangea. So your assignment day will be dealing with that, and I'll tell you more about that in our Canvas activity. Okay, oh, James almost put it together. All right, so look at the puzzle. All right, we were missing some pieces. So hopefully you like puzzles, and so your assignment day will be dealing with puzzles. Okay, thank you. See you later.